Okay, so today we are going to talk about the last day of transformations. Okay, and we're going to talk about a horizontal and vertical stretch and shrink. Okay, Chief and Wrigley are all snuggled up right now, but as always, apologize if you start hearing them barking. Wrigley already ate breakfast, so we're good with that. All right, so let's take a look at this first graph. This is a quadratic. This is the parent function. So we start at 0, 0. Go up 1, to the left and right 1, and then up 3, to the left and right 1. Okay. Remember that the pattern for a quadratic is 1A, 3A, 5A. If you ever forget, remember that you can always go ahead and plug in values to the left and the right of the vertex. Okay, so instead of actually making a chart today, we're just going to use the parent function and the transformations to graph each one. So if we look at this next one, we're going to go to the right 4. So we're going to take each point that we graphed on the blue line, or blue parabola, and we're going to go to the right 4. Okay. Once again, if you want to make sure that you did this correctly, then just take one of the ordered pairs. So let's say we take 5, 1, plug it in, and make sure you get 5, 1. Okay, the next graph is reflected over the x-axis due to the fact that there's this negative in front of the x squared, and then we're going to go up 2. So take each point, move it up 2, but now we're going to go down because we were reflected over the x-axis. And then finally, the next graph, we're going to go to the left 3. Remember, it's at the opposite on the inside of the parentheses. And we're going to go down 6. So take each point, left 3, and go down 6. Okay. So once again, if you're never not sure about the transformation, you can always plug in points. And then you can also plug in points to double check your work. Okay. All right, let's go ahead and take a look at the next graph. So here we have a square root, so I'm going to graph the parent function. Okay. Remember that a square root, the pattern is also 1A, 3A. It's just now that it's only half a parabola and it's on the side. Okay. Okay, so I want you to take the next two graphs, write down the transformations, and plot them on your own. So go ahead and pause the video, try it out, and then when you guys are ready, hit play. Okay, so here are the two graphs that you should have gotten. Notice that the red line just went left 3 and down 2. Okay, so that's this one right here, left 3 and down 2. And then the green one was reflected over the y-axis. So remember that when the x is negative on the inside, so we're actually multiplying the x values by -1, we're going to have to go to the left. We're going to reflect over the y-axis. So we went up 8 to start, and then we went to the left to reflect over the y-axis. Okay. All right, let's go ahead, and that was our review for the day. So let's go ahead and take a look at the next page. Okay, so horizontal and vertical shrinking and stretching. So notice that the multiplier, which is a, is on the outside of f of x. Okay, and remember that f of x are your y values. So we are multiplying the y values by this factor. Okay. And then remember that if the a value is negative, the graph reflects over the x-axis. It goes down for the y values. Okay. If the number in front of a is the absolute value of it is greater than 1, it's a vertical stretch. If it's between 0 and 1, it's a vertical shrink. So, for example, if we had f of x equals negative 3x, the absolute value of, let's actually, hold on. Let's change that to x squared. Okay. So then the absolute value of a is 3, so that's going to be a vertical stretch. Okay, so that means you're increasing faster between the y values. So it's going to stretch out vertically. So think about making yourself taller. That would be a vertical stretch. Okay, you have a vertical shrink if the absolute value of a is between 0 and 1. Okay, so vertical shrink. So the fraction will make you shorter. Okay. Now if we look at the multiplier inside the function, so notice that we are multiplying x by a this time on the inside of the function. We are going to affect the x values. Okay. And this time we're going to multiply by a factor of 1 over a. Okay, so all the x values will be multiplied by 1 over a. If the a value is negative, remember that it reflected over the y-axis. Okay, an example of this would be that square root function we just did, the green line. Now notice that the shrink and the stretch are different for horizontal. So if I have a vertical shrink, that's going to be in parentheses 3x squared. So notice that we're multiplying x by 3 first and then we're squaring it, versus up here we squared x first and then multiplied by negative 3. So in this example, we would have a vertical shrink because we would multiply all the x values by 1 over a. So we would multiply x by 1 over 3. Okay, so once again, that fraction is going to shrink me horizontally. Okay, and then we have f of x, let's say, equals negative 1/2 x squared. So first we'd have to multiply all the x's by negative, right, to make it reflect over the y-axis. But then when we multiply the x values, we have to multiply by the reciprocal of a, so that's going to be negative 2, creating a horizontal stretch. It's making me wider, okay? So you could think of shrink as thinner, okay, and a horizontal stretch as wider. Okay, so let's go ahead and practice these vertical and horizontal shrink and stretches. So if we take a look at the first problem, notice that the negative 2 is on the outside. So we would square, if we were plugging a value into x, we would square it first, and then we would multiply it by negative 2. So that's going to affect the y values, not the x. What we're plugging in stays the same. What we get back out changes due to the fact that we're multiplying this by negative 2. Okay, so our parent function is the parabola. Okay, and you don't need to draw the parent function every time. I just think for some people it helps. Okay, so if you can do this without drawing the parent function, you're fine. So all of my y values are going to separate by 2, okay? So we're going to multiply all the y values by -2. So either you can make an XY chart again and plug in values, or you can take each y value and multiply it by -2. So if I were to go ahead and list out these ordered pairs, we would have 1, 1, 2, 4, -2, 4, and -1, 1. Okay, 0, 0 is going to stay the same. And then I just need to multiply each value by -2. So my next ordered pair, if I'm looking at this one right here, is going to be 1, -2. Okay. And then on the opposite side, so if I'm looking at this one, I'm going to multiply the y value by -2. So I get -1, -2. Okay. Continuing along that pattern, if I go to this ordered pair, 2, 4, I'm going to multiply this y value by -2. So I get 2, -8. And then on the other side, I'll get -2, -8. Okay. So notice how from the parent graph that this is reflected over the x-axis, and when the absolute value of a is between 0 and 1 and we're having a multiplier to the y values, this is going to be a vertical stretch. I got taller. Okay, for the next example, first make notice of where the multiplier is. Okay, it's on the outside of the function. So what we're plugging in for x is not affected at all. So this means we're going to be affecting the y values again. Okay, and for our transformation then, we're going to multiply the y by 1/3. Okay, so if you need to, go ahead and graph the parent function. Okay, and then all of the y values are going to be multiplied by 1/3, or just recognize that this is the a value is 1/3, so we're going to go up 1 and over 3 each time. So up 1 over 3. Remember, v for absolute value. And here's my new graph. Okay. Notice that the absolute value of a was between 0 and 1, so I had a vertical shrink. Notice that I am shorter. I'm not as tall. Okay. All right, so let's go ahead and go to the next page. Okay. And first of all, for number 3, this needs to be the greatest integer function, in other words, the step function. So this should be around the 2x. Okay. Now notice where the 2 is. It's on the inside of the function. So that means when I'm multiplying x, these numbers are going to be affected before I take the greatest integer of it. So I don't think it's as simple as the vertical stretch and shrink to figure out these. So when you're doing a horizontal stretch or shrink, I would suggest making a table. Okay. So if I take -4 and I plug it in, I'm going to do 2 times 4, which is -8. Okay, remember that the greatest integer function means that any number is going to be equal to the integer that is less than it. So this is going to be -8. So I go to -4, -8, and plot my point. Okay, and then I'm still just going to go 1 over. Okay, because any of these numbers, okay, so from -4 to -3, when I plug them in, the least integer before it is going to be -8. Okay, so let's plug in a negative point. Let's say I plug in -3. That's going to be -6. So -3, -6. Okay. Then let's do -2. When I plug that in, that gives me -4. Okay. And hopefully we can see the pattern now and we can just fill it in. Okay. And there is your adjusted greatest integer function. Okay. All right. Let's go ahead and take a look at number 4. So this is a cube function. Okay. So the parent function for cube, remember the pattern is 1a, 7a. Okay. And the transformation is going to be to multiply the x values by the reciprocal of x, or the a value in front of x, which is going to be 2. So I'm going to take each one of these ordered pairs. So this is 1, 1, -1, 1, and we're going to multiply them by 2. Okay. All right, so the first one's going to stay 0, 0. But then if we take this ordered pair right here, I need to multiply the x values by 2. So my new ordered pair is going to be 2, 1. Okay. Then I'm going to take this ordered pair, multiply the x values by 2, and that gives me 4, 8. Okay. And then the pattern is going to work on the other side as well. So we're going to go to -2, -1, and then -4, -8. And here is our new graph. Okay. So the absolute value of a is going to be between 0 and 1. So that's going to be horizontal stretch. Okay, so notice that my graph got wider. Okay, so that's considered a horizontal stretch. I'm getting wider left and right. Okay, all right, let's go ahead and look at the next example. Okay, for this one, it's a cube again, so we can do the parent function. Write down all of our ordered pairs from there. And then after we're done doing that, go ahead and take a look. So we are going to multiply the y values by 2, because we're going to have a vertical stretch of down 6 then for our transformation. So after our vertical stretch, then we're going to go down 5. So we're going to subtract 5 5 from y. Okay, so now how do you know what order you should perform these operations in? Well, think of the order of operations. Multiplication comes first, plus when you plug in, let's say, an x here, of course you would take it to the third power first, then you would multiply by 2, and then you would subtract the 5. Okay, so let's go ahead and take a look at that very first ordered pair. I'm going to multiply the y value by 2, which is still just going to be 0, and then I'm going to subtract 5 from it. So my next ordered pair is 0, negative 5. Okay. Then for the next one, I'm going to multiply y by 2, so that gives me 2, and then I'm going to subtract 5, so that gives me negative 3. So my next ordered pair is 1, negative 3. Okay. Then we have up top, multiply 8 by 2, which is going to be 16, and then subtract 5, so that gives me 11, so 211. Okay. And then we're going to mirror the first one over here. And here is your new graph. So this is a vertical stretch. The absolute value of A was greater than 1. And notice that I'm getting taller. Okay. All right. We're getting closer. Let's go ahead and take a look at number 6. I want you to try this one on your own. Notice that you have to multiply y by negative 1/2, and then you're going to subtract 3 from x since you're going to the left 3. So let's go ahead and graph the parent function. Okay. So we have 0, 0, 1, 1, and then okay. And so following the transformations, we need to subtract 3 from x. So if I take this first ordered pair, I'm going to go to negative 3, and then multiply y by negative 1/2, but that's still going to be 0. For my next ordered pair for 1, 1, I'm going to subtract 3 from x, so that goes to negative 2, and then multiply by negative 1/2, so that's going to be just a negative 1/2. And then for the last one, for 2, sorry about that, subtract 3, so that's going to put me at 1, and then take 2 and multiply it by negative 1/2, so that gives me negative 1. Okay, so notice that I moved to the left 3 due to this, and then I reflected over the x-axis because this was negative, and then I had a vertical shrink because absolute value of A was between 0 and 1, so I got shorter. Okay, so we have one page left. Okay, so for this one, and we've been practicing this entire time, we are going to take the new points and let f of x be the points the following, and then apply the different information. So what I want you guys to do is, since we've been doing this entire time, I want you to go ahead and try this on your own. So pause the video, share your answers with your partner, and then go ahead and click play to check your answers. Okay, so here's what we should have gotten for all of them, with descriptions on what to do for each graph or each transformation. Okay, so the one that we probably struggled a little bit on was part B. So remember that when it is a horizontal factor, you multiply by the reciprocal of A, so in this case 1/3. It was on the inside of the parentheses, therefore we knew we had to affect x. And then the other one we probably struggled on was part D. Okay, because we had two transformations on the y values. We first had to multiply by -1, and then we had to add 2 to y. Okay, and then for the x values, multiply by 1/6. All right, since this was a long video, we're not going to do the last part of the notes. It's essentially what we've been doing on all the other graphs. Okay, your homework is to do worksheet 2.7, day 3. And I don't have my computer at home with me today, but I'll try to get the answer key up online so that you guys can check your work. And then just make sure that you are all caught up on Math Excel. Okay, so tomorrow we're going to do a free response and a concept check along with start looking at Desmos. And then Friday we're going to spend doing a Desmos activity. So this was pretty much the last new lesson for this week. Okay, hope you had a wonderful day, and thanks for listening.